Alright, 4.2 is right triangle trig, and this is where class starts to really get fun and take off and become exciting and all those other things. And so let's just dive in. And one of the things that we're going to talk about with right triangle trig is angles. And if you have your x and y axis and it looks like this, then the angles that we're going to be talking about will be the angles that are formed with the x-axis. So if we've got some line running off in this direction, then we're going to talk about an angle, and you'll see the Greek letter theta, and it's going to represent this angle between the red line and the x-axis. And so everything that we do with angles is going to deal with this relationship. And it's also going to work with right triangles. So we're going to talk about right triangle trig in this section. And so if I've got my right triangle here, then we would label the different parts of the triangle. We would call, like, maybe this guy would be theta right here. We would call our triangle ABC. It could be a right triangle. And we want to relate everything on this triangle to the angle theta. And so we label all these pieces in certain ways. All the way across the triangle, on the opposite side of the triangle, is the opposite leg. Opposite. Right next to the angle theta is the adjacent leg. It's adjacent. It's next to. And of course, the longest side of the triangle is the hypotenuse. Every single time you have a right triangle, you have a hypotenuse, and it's always going to be the longest side. So how do all these three sides go together with trig, you might ask? Well, here's how they all go together. We're going to deal with what's called the sine, cosine, and tangent. So we're going to deal with the sine, the cosine, and the tangent. And they all go together with this relationship right here. Whoa, I've got to get those guys out of the way. So we're going to deal with the sine, the cosine, and the tangent. And these are your relationships. And so the quicker that you can get these memorized, the easier your trig life will be. And one of the ways that I learned these guys that I really like is to think of them this way. You have the sine, so opposite over hypotenuse. The cosine, adjacent over hypotenuse. And toa, the opposite over the adjacent. And this is a really easy little quick way to remember how all these sine, cosine, and tangent guys go together. And then the reciprocals. These are reciprocals. These are reciprocals. The reciprocals. Notice the opposite goes from the top of the fraction here to the bottom of the fraction here. These are reciprocals. And that's the easiest way to remember them. And so the reciprocal of the sine is the cosecant. The reciprocal of the cosine is the secant, and the reciprocal of the tangent is the cotangent. So these are your basic right triangle sets. Okay? Let's look at a really famous right triangle right now, and it's one you've seen before. We just had it up on your notes here just a second ago, and it is a 45, 45, 90 right triangle. And we're going to have 45 degrees here. We're going to have 45 degrees here. And we're going to have our 90-degree right angle right here, 90 degrees. So, what are the sine, cosine, and tangents of these guys? Well, let's just say that the length of this side is 1. And if you're in a 45, 45, 90, we know that both of these sides have the exact same length. We'll call this side a 1. And we know that when we're dealing with a right triangle, we have a leg squared plus a leg squared is equal to hypotenuse squared. You might have seen it like this. A squared plus B squared equals C squared. And in this case, our A's and B's are 1. So we're looking at 1 squared plus 1 squared is C squared. Well, guess what? This is 2 equals c squared. C equals the square root of 2. There's my hypotenuse, the square root of 2. So if I want to run through all of the trig functions for these guys, let me just move these folks out of the way here. Then what we're going to look at is the sine. So, that's an H. Let me make that H really pretty. Toa. Okay. And so what's the sine? The sine for this guy? The sine of 45 degrees. And look, we can pick either 45 degrees. There's 2 of them. I'll go with this sine. Is the opposite over the hypotenuse. This answer is great. Some teachers don't like to see a radical in the denominator. We'll rationalize that guy real quick. And you get the square root of 2 over 2. That's fine. Both of these answers are acceptable in most cases. In most cases, these answers are both acceptable. Okay. Okay, so there's your sine. What about the cosine, you might ask? Well, that would be the cosine of 45 degrees. And guess what? The cosine is the adjacent over the hypotenuse. And hey, it's going to be the same thing. And the tangent of 45 degrees. That's going to be the opposite over the adjacent, or 1 over 1, which is 1. So there's your right triangles, and there's all your guys. Well, so I know that the sine of 45 is the square root of 2, is 1 over the square root of 2. I know that the cosine of 45 is 1 over the square root of 2. I know that the tangent of 45 is 1. So what about the cosecant, the secant, and the cotangent of 45 degrees on all of these? What is that going to be? Well, go back to a previous page. Look right here, up here in this corner. See these guys right here? These are your relationships. And so in that corner up there, we've got cosecant, secant, and cotangent. Okay? Notice that the cosecant goes with the sine. So what is the reciprocal of the sine? Well, the reciprocal of the sine is square root of 2 over 1. The reciprocal of the cosine is square root of 2 over 1. And the reciprocal of the cotangent is 1. How hard is that? Not hard at all. Easy money. Okay, so there's your basic trig functions on a 45, 45, 90 right triangle.